Good afternoon, girls. Children, let us begin the new topic today, revisiting irrational numbers. Now, you all know that we are studying today irrational numbers. You know that the rational numbers can be represented in the form of p by q. Q is not equal to 0, and p, where p and q have no common factor between them. This is what the rational numbers are. When we talk about irrational numbers, the irrational numbers are the numbers which we cannot write in the form of p by q. Yes, as it is, they don't have any common factor between them, so we will just write that we cannot write irrational numbers in the form of p by q, and q is not equal to 0. Now, based on this, we have in under irrational numbers we have some theorems. Those theorems we are going to study now. But before actually starting with the theorems, I will first revise what is a fundamental theorem. What is a fundamental theorem? It says that any positive integer composite can be expressed in the form of the product of the prime numbers. Okay, and this combination is, or this factorization is unique except the order of the factors. I repeat, the fundamental theorem of arithmetic says that the composite number can be expressed in the form of the product of the prime numbers. This prime factorization is unique, and the only change you can do is you can only change the order of the factors. Now, beginning with the theorems. Okay, now we start with theorem 1.3 and 1.4, and then we can proceed with the exercise. Okay, theorem 1.3. Now it says that let p be any prime number. Fine. Now p, if p divides a square, then p also divides a. And what is a? A is any positive integer. Okay, again, let p be any prime number. If p divides a square, then p also divides a, and a is a positive integer. So let us begin with the proof. Let the factorization of a b. We are talking about the prime factorization. So a will be equal to p1 into p2 into p3, and we don't know the number of factors, so we will just write with pn. Okay, so therefore I can write p1, p2, p3 and pn. Now and what is p1, p2 and this? They are all prime numbers. Okay, now from the okay, now this is 1. Okay, now what will be a square? This is a. What will be a square? A square will be p1, p2 up to pn multiplied by again p1, p2, p3 up to what? Pn, if I include p3 here. So this into this will give you a square. Now this factorization, you know, is unique according to what? According to the fundamental theorem of arithmetic. Okay, now it is given that when it is saying that p divides a square, okay, it is given that p divides a square, and we also know that this is a factorization of a square. So therefore we can say that p is one of p1, p2, p3 and so on till pn. Okay, therefore, if P is dividing A square, P will be one of the P1, P2, P3. Therefore, as you can see the factors of A. Now look at the factors of A. We know that A is P1, P2, P3 and Pn. Since I said, or since we wrote that P is one of P1, P2, therefore P divides A. This is what we had to prove, and this finishes the theorem. Okay, and now using this we are going to prove that root 2 is irrational. Okay, or we can prove that root 3 is irrational. Starting with this one, let root 2 be a rational number. We are going to prove these theorems with the contradictory, or we are going to assume that root 2 is a rational number. Now when root 2 is a rational number, we can write root 2 in the form of p by q. And what is this? Q is not equal to 0, and p and q have no common factor between them. Fine? See, we are assuming that root 2 is a rational number. Now, root 2 is p by q. On squaring, root 2 square is equal to p square upon q square, or we can write p square is equal to 2q square. Okay, this will be 2 and it will go here. Now as you can see with this condition, that since p square is divisible by 2, if I bring this 2 down, it is, or we can say that p square is a multiple of 2. We can also say that p square is divisible by 2. So therefore by the first theorem, p is also divisible by 2. By which theorem? By this theorem, the previous one, 1.3. Now when p square is divisible by 2 and p is also divisible by 2, this I name it as number 1. Now let p be equal to 2m. Therefore I can write p square is equal to 2m square whole square, which is equal to 4m square. Now by 1 and 2, here it is 2q square and this is 4m square. I can write by 1 and 2, 4m square 2q square is equal to 4m square. Or I can write it as q square is equal to 2m square. Here I got, so here I got that p square is divisible by 2 and p is also divisible by 2. From here I will get q square is divisible by 2 and therefore q is also divisible by 2. So did you follow that? Now p, so I will write here, therefore p and q both are divisible by 2. But according to our assumption, we have assumed that root 2 is equal to p by q. Okay, q is not equal to 0 and p and q have no common factor. Therefore this assumption, our assumption is wrong. The above statement is contradictory to our assumption. We can write this first, that the above statement is contradictory to our assumption, hence our assumption is wrong. Therefore root 2 is an irrational number. Fine, this is how we'll prove the root 2 is an irrational number. Similarly, we can prove that root 3 is also irrational. Okay, now similarly same thing we can write, let root 3 be a rational number. The same procedure, the only thing is instead of 2 here, we will get that both are divisible by 3. Okay, so we can proceed. Let root 3 be a rational number. Root 3 will be p by q. So therefore, p square upon q square will be equal to 3. Hence, p square is equal to 3q square. Now here we know that p square is divisible by what? 3. Therefore, p is divisible by 3. This is by which theorem? By the first theorem 1.3. And similarly, let p will be equal to 3m, not 2m, 3m. If I take p as 3m, I can write p square as 9m square. From here this is 1, here this is 2. When I equate 1 and 2, I will get 3q square is equal to 9m square. And I can also write it as q square is equal to 3m square. So q square is divisible by 3 or q is divisible by 3. So when I look at this and when I look at this point and this point, we now write that p and q we now write that p and q are both divisible by 3. Yes, so therefore the statement, this statement is contradicting the main statement. What is our main statement? That let root 3 be p by q. They do not have any common factor between them, and here we are getting that they are both divisible by 3. Okay, so therefore our assumption is wrong. Our assumption is wrong. Hence, root 3 is an irrational number. So children, you will complete these 2-3 theorems. So here I have completed today 1.3, 1.4 and 1.5. Okay, as you can see, example 9. Now you have the exercise 1.3. You can try these questions. Okay, I'll give you the proof of these. I will send it in the WhatsApp group. You can go through them. If you have any doubt, you can ask me. And today you complete 1.3. Okay, and then we'll go to the rational numbers and the decimal expansion. Okay, thank you. Have a good day.